In this lesson, you're going to be introduced to complex numbers. Complex numbers came as a result of needing to take square roots of negative numbers. Now, you're familiar with solving equations like m squared equals 9. You know the solution is positive 3 and negative 3 when you took the square root. Similarly, you solved x squared equals 0, and you had the solution of 0. However, in the past, y squared equals negative 25 could not be solved. We would just write no real solutions. Well, imaginary numbers, the imaginary unit I, allows us to take the square root of a negative number. So if you look over here, we have that I is equal to the square root of negative 1. And from that, we're going to build on a lot of other things. Let's first do a few examples. All right, if we have radical 3 times radical 3, that is the square root of 3 times 3, which is the square root of 9, which equals 3. And I hope you noticed that we end up, our answer is one of the numbers that was underneath the radical. So below, where we have I squared, and I wrote as square root of negative 1 times the square root of negative 1, our solution is just going to be negative 1. And all I'm doing is following the pattern that's above. Let's look at, what about when you have I to the third power? Well, I to the third power would be I times I times I. And we already said that I squared is negative 1. So this is negative 1 times I. And usually use a script I. And that gives us negative I. Just mark these answers. Okay, what about I to the fourth power? Well, I would break that down as I squared times I squared. And I squared, we showed earlier, is negative 1 times negative 1. And that equals positive 1. And finally, I to the fifth power, we could look at it as I to the fourth power times I to the first power, or just I. And I to the fourth power, as we see above, is positive 1, and 1 times I is I. What I want you to do next on your own is complete this table and then look for any patterns. Once you figure out if there is a pattern, try to figure out these parts over here. Okay, let's simplify some radicals when there's a negative underneath. So the square root of negative 3. All right, I would break that down as the square root of negative 1 times 3. Now in the future, you may not need to do all these steps, but I want to show you where everything comes from. So since they're both raised to the 1/2 power, which is what square root is, I could say this is the negative 1 times 3. And we saw before that the square root of negative 1 is I. And radical 3, well, it would be a decimal, so let's just leave it as precise. So our final answer here would be I radical 3. What about the next one here? Square root of negative 49. This one, the breakdown is the square root of 49 times the square root of negative 1. I usually put the perfect squares first, and you'll see why in a second. Square root of 49 is 7, and square root of negative 1 is I. So this is 7i. And square root of negative 52. Okay, the largest perfect square I know that will divide into that is 4. Just a quick list of perfect squares. And you always want to divide by the largest one. All right, the way I will break this down is I'll put the square root of 4 first, square root of negative 1, and square root of 13. Final answer, 2i radical 13. All right, how can we apply this to solving quadratics? So we have a quadratic equation, x squared equals negative 49. Now before we couldn't solve this. However, with I, we're able to solve it. Take the square root of x squared, square root of negative 49. On the left side I get x. Now I simplified square root of negative 49 earlier as 7i. As you can see there. So I'll put 7i. But you have to remember that when you're solving an equation, you have both the positive root and the negative root. So don't forget to put plus or minus in front of your solution. I will do a quick check for this one. You could check both. I will check 7i, and I will square it. And I want to see if it equals negative 49. Well, 7i squared is 7i times 7i. 7 times 7 gives me 49. And I times I, which is I squared, gives me negative 1. 49 times negative 1 is negative 49. So that indeed is correct. If I had a negative in front, well, negative times a negative is positive. So it would still give me positive 49, and then it would end up being negative 49. So they both work. All right, how about this one over here? Well, the first thing we want to do is isolate the x squared over here. So work farthest out, move your way in. I'll subtract 11 first, both sides. And I have negative 3x squared is equal to 240. Next, I will divide by negative 3. And I'll continue that on the other side. I have x squared is equal to negative 80. And here we take the square root of both sides. And the square root of negative 80. Maybe you want to simplify that first before you jump to the answer. So think of what's the largest perfect square that will divide into 80. 4 would be good, 4 times 20, but 20 can be broken down more. So this is actually the better one, 16. So negative 80, I will look at it, negative 16 times negative 1 times 5, all underneath the radical. So what's my final answer? X equals 4i radical 5, and don't forget the plus or minus. Take a moment now to check that answer into the equation and verify that it works. Also gives you a good chance to practice your properties with I. Okay, complex numbers can be written in standard form. Whenever we write them in standard form, we put the real part, which is A, first, and the imaginary part second. If you look at the table over here, we have all the complex numbers could be broken down into either real numbers or imaginary numbers. Anything with an I is an imaginary number. You can have imaginary numbers with a real part or pure imaginary numbers like -4i and 6i. Here are a few visual aids to help you see this. Everything here on the outside is a complex number. So for example, whole numbers start on the inside here, and then integers, rational numbers, all real numbers, and irrational numbers are real numbers, pi, square root of 2, and then the next category of numbers is complex numbers that have their own section of imaginary. And here's another way to look at real numbers. A whole number would be 0, 1, 2, 3, etc. You have another section of natural numbers over here, which would drop to 0 and just have 1, 2, 3, 4, the way you learn how to count. Integers, we have positive and negative whole numbers. So -2, -1, 0, 1, 2. They go on forever. Rational numbers. Any number that can be written as a ratio using integers. So 2/3, 7/1, 18 over -41, all that. And all of those numbers are real numbers, as are irrational numbers. Pi, square root of 2, square root of 17, square root of 80. Basically anything that you put in a calculator that doesn't terminate, the decimal goes on forever, and there is no repeating pattern. Okay, the key is no repeating pattern. Rational number, like 1/7, does have a decimal that continues infinitely, but there is a pattern. That's why it's rational. Let's move on. When you're adding or subtracting complex numbers, same rules as before. Remember to distribute the negative when subtracting. Let's try a few. All right, I have a binomial plus a binomial. When you're adding two complex numbers, just drop the parentheses and then combine like terms. So I will combine the real part first, this 10 with this -33. That's kind of what it shows you here. Put the real parts together. That gives me -23. And then I have +1i and +7i. That gives me +8i. So there's a solution. And what about if we had the same thing, but this time it was being subtracted? Well, if that's the case, remember that old rule you had, keep, change, change, and later in algebra it just became that you have to distribute the negative. So we keep the first term, 10 plus I, and now we distribute the negative. That gives us negative 7i plus 33. And now same thing as before. Combine like terms. So 10 plus 33 gives me 43. And positive 1i minus 7i, negative 6i. If your calculator has an I button, try this out. Enter these numbers with I, and your calculator should be able to do this calculation, including I to whatever power, and most other things we do. Graphing calculators especially have an I button, so just try that out right now. Multiply complex numbers the same way you multiply other algebraic expressions. You distribute, combine like terms, simplify, whatever it takes. You treat it almost the same way you would a regular variable, except for one important part, and that is that I squared is negative 1. So whenever you have a chance to simplify any I with a larger exponent than 1, you should go ahead and do that. All right, so here I have a negative 4, and maybe if you want, write it this way so you can see it better. And I will distribute that. Negative 4 times 2i is negative 8i, and negative 4 times negative 7, positive 28. I bring the other terms down. And I to the third power, remember it's I squared times I, and I squared is negative 1. Bring down the I. And now we could combine like terms. The 10 plus 28 is 38. And then we have negative 5i minus 8i minus 1i. They're all like terms. Combine the leading coefficients and we get negative 4i. And just remember to always write your final answer with the real part first and then the complex part. Okay, let's try another one. We have a binomial times a binomial. We're going to distribute. I know some of you call it by a 4-letter word that starts with F that I won't mention here, but let's call it distribution because that's what it is. So we distribute the 5. All right, 5 times negative 7i is negative 35i. 5 times 1.4, you can do that mentally, just break it down. 5 times 1 is 5. 5 times 0.4 would give you 2, so that's plus 7. And distribute the 3i. I have negative 21 I squared. That's key, that I squared, don't forget that. And then 3i times 1.4. 3 times 14 would give you 42. Move the decimal over. So it's 4.2 I. And normally here you would just combine the I parts. And before you would have a quadratic expression. However, here we could also simplify the negative 21i squared. So I could do that down here on the side. Negative 21 I squared. We said that I squared is negative 1. So that gives us positive 21. So all this becomes negative 35 I plus 7 plus 21 plus 4.2 I. And now we can combine the like terms. So the real parts first. 7 plus 21, that's 28. And negative 35 plus 4.2, it's going to be negative. And 35 minus 4.2 would be 30.8 I. Stays negative. And that is our final answer.